Bismillahirrahmanirrahim. Welcome to the Rising Star Academy. Today we will learn how to express a Cartesian coordinates into a polar form in complex numbers. So, in this question, the value that is given to us. So, let's start. We will take let z is equals to minus 1 plus 2 iota. So, we know that the normal complex number is z equals to a plus iota b, that is the Cartesian coordinate. So when we convert into polar form, then polar form would be z is equals to r times cos of theta plus iota sine theta. Or simply we can say that the a comma b is given to us. We need to convert them into r theta. R is the distance and theta is the direction or angle. So let's start. First of all, we need to find R. Basically, that is the modulus, Z mod. So in modulus, we will write the formula, that is A square plus B square. This is my A value. This is my B value. So let's write the coefficients. So negative 1 square plus 2 square. That would be negative 1 square is 1, 2 square is 4. So the r is equals to square root of 5. So this is my r value or the modulus. Next we will find the argument. So alpha is equals to tan inverse of b over a, or sometime we can write y over x. So the value of b is 2 and value of x a is negative 1. So tan inverse of 2 over minus 1. We will write tan inverse of minus 2. Negative sign we will take in before the tan. So that is tan inverse of 2. Now we know that the x and y values are lying in the second quad, because here x is negative and y value is positive, or we can say that a is negative and b is positive. So it lies in the second quadrant. In second quadrant, what would be the angle in that case? So here we can see in second quadrant we will add pi into the basic angle, that is alpha. So let's write. So theta is equals to alpha plus pi. The alpha is minus tan inverse of 2 plus pi. We can write it the value in radian form. So you will use the calculator. So here we need to convert our calculator into the radian modes. So shift with mode. So option number 4, that is a radian mode. So we will write negative shift tan inverse of 2. So the value will become minus 1.107 plus the pi value is 3.142. So we will add 3.142. The answer will become 2.035. So now we will write our final answer. So the final answer would be z is equals to r times cos of theta 2.035 plus let me write again. So z is equals to root of 5 times cos of 2.035 plus iota sine 2.035. This is my final answer into a polar form. We'll move to the next question now. In this question, we will write z is equals to minus 1 plus 4 iota. So first of all, we will find r, z modulus. So that would become negative 1 square plus 4 square. That would become plus 1 plus 16. So the final answer would be square root of 17. Now we find alpha. So tan inverse of b value over a value. So that would become negative tan inverse of 4. So the value is lying in the second quadrant. So in second quadrant, the theta will become alpha plus pi. So I will write the value of alpha now. That would be negative tan inverse of 4 plus pi. So I would use the calculator to convert the value in decimals. So negative shift negative, then shift tan inverse of 4. That would become minus 1.3258. We will add 3.14 to the value of pi. So the final answer would be 1.8162. So now I will convert this value or put in this value in polar form. So we will write z is equals to r times cos theta plus iota sine theta. So the value of r is square root of 17. Then cos of theta value, the theta value is 1.18162. 1.18162 plus iota sine, then let me write it again. So the cos 1.8162 plus iota sine 1.8162. So this is my final answer. Now we'll move to the next. In this problem, let z is equals to 0 minus 4 iota, because the real part is 0, so only imaginary part is given to us. So let's find r. So 0 square plus minus 4 square, that would become 0 plus 16. So square root of 16, that is equals to 4. Now we will find the value of alpha, that is tan inverse of minus 4 over 0. So tan inverse of negative infinity. So tan infinity, that is basically negative pi by 2. So the 0 is positive and negative 4 iota is negative, so this value is lying in the fourth quadrant. Here we can see the x is positive and y is negative, so the alpha would be remain the same, so it means our theta would become negative pi over 2. Now we will write the final answer. So z is equals to r times cos of theta plus iota sine of theta. So value of r is 4 cos of negative pi by 2 plus iota sine of negative pi by 2. We know that the cos of negative theta is positive cos theta. So due to this rule, we can write cos of pi by 2, and sine of negative theta can be written as negative sine theta. So that would become negative iota sine into pi by 2. So this is my final answer. Now in this question we have z is equals to 2 plus 0 iota. Only the real part is given and imaginary part is 0. So we will find z mod, that is equals to r. So 2 square plus 0 square, that would become 4 plus 0. So the answer is 2. Next, the alpha, that is tan inverse of iota, that is having a coefficient of 0 over 2. So tan inverse of 0 over 2, that would become 0, and tan inverse of 0 will become 0. So our final answer, z is equals to r times cos of theta plus iota sine of theta. We will put the value, that would become 2 times cos of 0 plus iota times sine of 0. So that would be our final answer in polar form. Thank you very much.